This is 4.2, still functions. Let's get straight into it. So we have these two functions given below are the functions of P and R. P is this one. Okay, let's highlight it there for us. P is this one. Okay, let's just chat about that quickly before we continue, before we even look at the questions. As soon as you see this, you must be able to identify what kind of function this is. So you should notice x has a 1 as an exponent. So this is y is equal to mx plus c. What equation is that? That's the equation of a straight line. So you should be able to see that your m value, which is our gradient, is a 1 in this function. So what does a positive gradient look like? It goes up. Negative gradient, that goes down. What does the c value tell us? C value, similarly, I think it was in the previous video we mentioned, whenever you have a graph plus a certain number, that moves it up and down. So our c here shifts our graph up and down, but also the c value is the y value of the y-intercept. Okay, we'll probably need some of those things later on, but as soon as you see that equation, you should know everything that you know about a straight line graph. The second equation that we see there is this one, r, and r is equal to a over x plus q. Okay, so some unknowns that we're going to have to find out, I'm sure, but what you should recognize is that that equation is the equation of your hyperbola. All right, so you have y equals a over x minus p plus q. That's your general equation for the equation of a hyperbola. And let's maybe talk about the q first here. So what you should know, and we mentioned it above, was whenever you have a graph plus something, that thing moves it up and down. So your q shifts your graph up and down. And then the p, your p value is going to shift your graph left and right. Okay, for all your functions, if there's a p, it's probably going left and right, q going up and down. Then you also have this a over here, and what we know for our hyperbola is if a is positive, that determines our quadrants, right? So positive a is going to be first and third, and obviously negative a will be second and fourth. So as soon as you see the equation, you should know a ton of things. Okay, so the again, before we even looked at the picture, we know that's a straight line, that's a hyperbola. All right, let's get into the questions. Write down the coordinate of C. C is over here, and I think we already mentioned it. That's your y-intercept. So how are you going to find your y-intercept of your straight line? Well, we mentioned it earlier. We can say the C value is the y value of the y-intercept, but in order to find your y-intercept of any graph, y-intercept for any function, it's always going to be making x equal to 0. So what is your equation of your straight line there? Quickly, let's double check. P of x equals x minus 2. So we can say y is equal to x minus 2. We could have written y. We could have also said p of x instead of y. Those are the same thing. Okay, anyway, so if you want to find your y-intercept, x is going to be a 0. So this is going to be 0 minus 2, which is just minus 2. Coordinate for that c is going to be x was 0 and y was minus 2. Right, let's see what is next in our question. Write down the numerical value of q. Okay, so q, we spoke about it there. Q shifts the graph up and down. Okay, what we maybe didn't mention was, as much as q shifts your graph up and down for your hyperbola, q also tells you your horizontal asymptote. That's this one, horizontal asymptote, and your p value, which we did refer to earlier, would be your vertical asymptote. So this graph, we've moved it down, we didn't move it left or right. So how many units down did we go? So if c is at 0 minus 2, then obviously our hyperbola went down 2 units. Why 2 units? Because the c value is minus 2. So the straight line cuts at minus 2. So minus 2 is the horizontal asymptote for your hyperbola. Right, so they wanted the q. So we say q is equal to minus 2. Okay, let's see what's the next question over there before we discuss the equations. Right, the coordinate of b is over here. So what is b? That's the x-intercept, right? So how do you find x-intercepts? Again, this is the equation of my straight line. my equation of my straight line is y is equal to x minus 2. So we have the y-intercept above. How do you get the x-intercept? In order to find the x-intercept, y must now be 0. Okay, so this is y, and we're going to make that 0. So 0 is equal to x minus 2. Let's add that on both sides. So 2 is equal to x. We like to have our variable on the left hand side, so I'm going to say x equals 2 instead of 2 is equal to x, but it really is the same thing. So what is the equation then? The x value is 2, the y, well, not the equation, the coordinate. X value is 2, y value is 0, and this coordinate's name was b. Let's get back to our picture. So we've got our C, we've got our B, the equation of R. Okay, so what do we have? We have the Q value, which we found is minus 2. So how many unknowns do we have? Okay, let's write the equation quickly. So we have y, this is the equation of the hyperbola. Y is equal to a over x minus 2. Right, remember this thing is the same as r of x. Okay, so if I said r of x or if I said y, it's really the same thing. If I look at this equation here, there is only one unknown. Y and x are not unknowns, y and x are variables, right? Because on the same graph, y and x will be different values. But this a value is an unknown. So there's one unknown. And if you have one unknown, you need one coordinate. One unknown, one coordinate. Let's go look back at our picture and let's see if we do have one coordinate on our hyperbola. Okay, where's the hyperbola? Hyperbola is this one. Do you have one coordinate on your hyperbola? Sure you do. You have a, and a is minus 2 and 0. So we're going to take coordinate a and we're going to substitute it into the equation of the hyperbola, which is where we are over here. Right, so we're going to say y is equal to, what is the coordinate that we're substituting? Minus 2 and 0. So so a is what we want to find, x and minus 2. So we're going to replace, let's get the eraser here. We're going to replace x and we're going to make x minus 2. And we're going to replace y and we're going to make y 0. So what did we do? We substituted the coordinate a into the equation of the hyperbola. And now we only have one missing variable, that's the a. Now we need to solve for a. Okay, so what we're going to do, we're going to add 2 on both sides. So there's going to be 2 is equal to a divided by negative 2. You want a alone, so you're going to multiply both sides with a negative 2. That negative 2, this cancels with that. So on your right hand side, you only have a. On your left hand side, 2 times minus 2 is negative 4. So your equation is going to be, I'm going to write it again as the r of x is equal to negative 4. This gets divided by x, and your q value was minus 2. Right, what did we just do? We did this. We got the q value from the earlier question that we solved. You had this equation which only had one unknown. The one unknown is a, x and y are variables. If you have one unknown, you need one coordinate. The coordinate we had was also here, a, which is minus 2 and 0, and we substituted our coordinate into our equation, and then we found our missing variable, or not, our unknown, which was a. Then we substituted a back into the equation of r, and now we have the equation of the hyperbola. Let's see, what do we still need to do? Write down the range. Right, so what is range? I think in the previous video we spoke about domain. Range is all possible y values. Okay, so I'm going to do something called a horizontal line test. So earlier we did a vertical line test. Now I'm going to do a horizontal line. So horizontal line test, I'm going to draw a couple of horizontal lines and see, okay, let me just leave one there for now. So they have drawn a horizontal line. Does the horizontal line touch my r is hyperbola? Does my horizontal line touch the hyperbola? Yes, it does there. If I move, let's put that in another color so we can see it there. If I move my horizontal line up, okay, so if I draw another horizontal line slightly higher, does it still touch? Okay, so does that still touch my graph? Yes, it does. It touches there. If I take the horizontal line and I keep moving it up, am I always going to touch my graph? If I go up there, sure, it touches over there. But there is a point, or there is a place where the horizontal line will not touch my graph, and that's going to be here. Right, and what is that? That's our asymptote. So if I draw horizontal lines, it will always touch my hyperbola besides at the asymptote. Right? So what's my range going to be? Range all possible y values. So we're going to say that y is an element of real numbers. That means y can be all real numbers. But we're also going to say that there is one value y can't be, and that's the asymptote. So we're going to say y can't be the asymptote, which was -2. So what does that mean? Those horizontal lines will always touch the graph. Doesn't matter where we draw it or how we move it. The only time it won't touch is when y is equal to -2. Why doesn't it touch there? Because that's your asymptote. Are we done with the question? One more. Write down the value or values of x for which p times r is smaller than 0. Okay, let's talk about that part first. Or maybe we should talk about the second part first, because it might make the question slightly easier. Although it's going to be a bit cluttered because of all of the stuff that we wrote on. Anyway, let's talk about it. So the second part here says x is smaller than 0. X is smaller than 0 solely. Okay, let me just change the color here. Maybe it will help. X is smaller than 0 only on this side of your y-axis. Everything on the right-hand side, x is bigger than 0. Okay, so in order to answer this question, I can only look at the left-hand side of my y-axis. Okay, because on my right-hand side, it doesn't meet this requirement. Okay, so now let's talk about what this means. This means the one graph, which is p, that's the straight line, is multiplying by the other graph, which is r. Okay, so remember earlier we instead of using these values or those symbols, we replaced it with a y. Okay, so this is what we're going to think. The y value of this graph times the y value of that graph must be smaller than 0. Okay, so what is smaller than 0? Smaller than 0 is negative. Smaller than 0 is negative. So what are we saying? We're saying the two graphs multiply and they produce a negative answer. Right, what does that mean? Or let's ask this. When do two things multiply and produce a negative answer? Two things multiply and produce a negative answer if one of them are negative and the other one is positive. Does that make sense? Right, so what I'm saying is, in order to find out where the two graphs okay, let's get that back. Let's get a pencil here. In order to find out whether one graph times the other graph is smaller than 0, one of the graphs must be positive, one of the graphs must be negative, and then they multiply and produce a negative. So it's a bit difficult to see with all of the things that I've written on my graph. Maybe I should just draw a new one quickly. Okay, right, so I'm only going to draw the left hand side for us. And we have our straight line graph that looks like this, and we have our hyperbola that looks like this. Okay, let me put in the points of interest. That's the wrong direction. This point over here is -2. This point over here, the x value is 0, the y value is -2, and this point over here, doesn't really matter because we said we are only looking on the left hand side of the y-axis. Okay, so this is what the question means. Both graphs need to be different. One must be positive, one must be negative. Okay, so let's do this. I'm going to draw in a vertical line. Okay, at this vertical line, this graph is at the bottom. This graph is also at the bottom. Okay, so when I say they're at the bottom, this has a negative y value, this has a negative y value. So both graphs are negative at that vertical line. So if I take the one y and I multiply it with the other y, it's two negative values multiplying. And if two negative values multiply, they produce a negative. Okay, I'm going to draw another line. Again, yeah, both of them are at the bottom. So still negative. Okay, what about if I go here? That one is on top, so it's positive. This one is at the bottom. So the one is on top, the one is positive, the one's at the bottom, the one is negative. So if I take a positive value and I multiply it with a negative value, then I will have a negative answer. Okay, so what we're looking for is where one of the graphs is on top and the other graph is at the bottom. And we notice that this line that we drew, that meets that requirement. So the question is, where does it start being one on top, one at the bottom? And where does it stop being one on top, one at the bottom? So I'm going to let me change my color here and I'll give you the answer. Okay. If I look here, everywhere on the right hand side of this line, the one graph is on top and the other graph is at the bottom. And then when we go, okay, the requirement was that we're not allowed to go beyond there. So everywhere inside this space, the one graph is on top and the other graph is at the bottom. And when I say on top and at the bottom, I'm referring to my y-axis, my x-axis, sorry, this x-axis line. So the y values are on top and the y values are at the bottom. Right? So how am I going to express this answer? The answer looks something like this. From -2 up until 0, the one graph is on top and the other one's at the bottom. So x is going to be in the middle and I will have my inequalities like this. Obviously, well, maybe not obvious, but this value, it's touching 0. So if it multiplies, that produces a 0. So we can't include that value. Similarly, on the other side, they gave us the restriction to say that x must be bigger than 0, so it can't be equal to. So what I'm saying is we don't have those lines underneath. Okay, so that over there is our answer for that question. Bit of a longer video, but try and work through that. And just let's look at this again. Okay, the one graph times the other graph have to be smaller than 0, so they must produce a negative. So the one graph's on top, other graphs at the bottom, that's where they produce a negative when multiplied. All right, good luck.